Thank you. I know we're standing between you and break, so we'll try to make this quick here. Last year at this conference, I stood up here and talked about a project that we worked on that used VISIM, VIZOOM, and VSTRO to do a light rail project. And we talked about some lessons learned last year, and we even had some follow-up conversations with PTV about it. And so this year, this is kind of like part two. We have another project that we worked on in the last year. Same kind of thing, VISIM, VIZOOM, and VSTRO, and we decided to use some of those lessons we learned last year and kind of give you an update on how that went. So I'm Joe Blasey. I'm here with my colleague Zach Cowart. We're with HNTB in Kansas City, and we're going to talk about using all three of those PTV products as it pertains to a project we did in Louisiana on a bus rapid transit project. So we'll talk about the specific project that we use this approach on. Zach's going to talk about go through the details of the model development process, and then we'll talk about some of the lessons learned this time and some more improvements that maybe could be made to the process or to the PTV software. So a little bit of background. This project is in Louisiana. It's in Baton Rouge, which is in the southeast portion of the state along the Mississippi River. It's the capital of Louisiana. Our BRT route, you can see downtown Baton Rouge kind of in the middle on the left there along the Mississippi River. Our project runs from a new North Transit Center up at the north end in the top right of the map there, down through downtown following the yellow highlighted route. That diagonal road is Plank Road, down into downtown, through downtown, and then down south along Nicholson Avenue. No, Drive. Shoot, Nicholson Drive, down to Louisiana State University, or LSU. I'm sure many of you have heard of that school before. Okay, a little bit more about the project background. So this is, I guess I would call this kind of a BRT light type application. It's the first one that the city of Baton Rouge is looking to implement. So we're going to maintain existing lanes for the most part, and we're not proposing any dedicated bus lanes for this project. There are up to 37,000 ADT in 2021 in some parts of the corridor. We are implementing some enhanced pedestrian facilities as part of the project, especially around the station locations. Like I said, we don't have dedicated BRT lanes, so these buses will be running with mixed traffic, with general purpose traffic. And then we did implement, or we want to implement, transit signal priority, and so we're modeling TSP in this project. So why did we, or what are the purposes of our model? Why did we want to model this in detail? One, we wanted to analyze the interaction of modes, and particularly the bus mode with the general purpose traffic. We wanted to test some geometric changes in the network. Again, we're not making big changes. We're not taking away lanes, but we are making some tweaks at the intersections with turn lanes and storage bay lengths. And then we use the model to help with the service planning for the buses. So we're looking at running times from end to end and feeding that to our service planning team so they can put together the schedules. And then we wanted to look at the impacts of TSP. So what are the benefits to the buses, and then what are the impacts to general purpose vehicles? Because we need to sell might not be the right word, but at least make the city and the stakeholders and the decision makers aware of these impacts before they sign off on it. And so now I'll turn it over to Zach to talk a little bit about our process.
All right. So as Joe mentioned, last year they presented on basically this process here. So this is what they presented last year. Stole the slide. They started in Synchro and then moved to VISIM and VSTRO and went and use Basum. And we use those lessons learned this time to have a more efficient process. And since this is the PTV conference and to make Adam happy, we decided to kick Synchro altogether and start our modeling process in Vistro. And so we started with Vistro to code our geometry, code in our signal timings, and then export that to Basum, and then eventually to Visum as well. So our existing model process here, like I said, we started in Vistro. We coded in the base network, all of our intersection geometry, the provided signal timings and phasing, all of our traffic counts, exported that to Basum to create our peak hour origin destination matrix. Use that Vistro model to import into Visum with our RBC files that were already coded. Did some cleanup with the Visum geometry and RBC coding, and then imported our static vehicle routes from Visum into that Visum model to start running our existing calibration. So our existing model, our calibration was to the AM and PM peak hours. We calibrated to our field travel times, turning movements, and field observations. The image you can see there in the bottom left-hand side of the screen is of the south end of our corridor down near the LSU campus. Some pretty significant queuing in the southbound and northbound directions. Then for our future model development process, we decided to use Scenario Manager for the first time. This was a bit of our learning process. And so we started with our AM and PM calibrated models separately, and then used our AM model as our base, and had to create a PM transfer file, as Joe will talk about a little later in our lessons learned, make our signal timing modifications, geometry modifications to develop future no build and build BRT scenarios with and without TSP. So going into the different softwares that we use, beginning with Vistro, like I said, we code our existing geometry for 38 signalized intersections, and then intersections in between for right-in, right-outs for the volume balancing process. Imported those raw traffic counts, and like I mentioned, balanced traffic volumes using Vistro's visual volume balancing capabilities. And coded in our existing phasing and signal timings that were provided by the city of Baton Rouge and Parish. And then for our future scenarios, we exported our balanced AM and PM volumes, CSV files in Excel, and then grew those in our spreadsheet, and then imported them back into Vistro to create our future no build models. And we're able to use the future volumes to optimize our signal timings to import directly into our Visum model down the line. So here you can see we had 9 different coordination groups here in Vistro. So then moving into Visum, we imported our Vistro network to get our base kind of stick diagram with our nodes, and then coded in our zones and connectors in order to start our OD process. Started with a seed OD, where we assign just kind of a relative volume to all of our different possible routes. And then using the T-flow fuzzy feature, we were able to solve the OD matrix. It was 114 by 114 OD that Joe wanted me to solve by hand, but I had this great Visum idea. So we used the T-flow fuzzy to tighten the tolerances and balance to our turning movement counts. And the other big benefit of Visum here was we were able to export our Visum static vehicle routes and relative flows directly from Visum into our models, which saved us a lot of time. So then in Visum, like I said, we did our existing model calibration. Here's an image of our full corridor from the north to the south at the LSU campus. We then utilize the scenario manager for all of our future scenarios. You can see all our scenarios and our different modifications there beneath. Developed our future no build model. So we used some optimized timings for the future no build to try to improve the signal or the queues that were occurring down on the south end. You can see here where it's continuing to get worse still. And then we developed our BRT base model. And so there we incorporated all the geometric changes from the design team, coded in all of our new bus routes, updated our stop locations, and used that to compare to our future no build scenario. And then we coded the BRT with TSP. And so to do that, we used the early extend feature with 15 seconds of early extend on each side, and our check-in, check-out detectors, as you can see there on that image on the right, the check-in detectors on the south side are placed just north of the last transit stop there. And then our checkout detectors are on either side of our traffic signal. The check-in detector to the north is actually for the intersection that is further downstream that's not shown. And so with that, we're currently still in the process of evaluating these TSP results, but we're currently showing anywhere from about 5 to 8 minutes of travel time saving, or reduced travel times for the BRT bus in the peak hours. And with that, I will turn it back over to Joe.
I originally thought Zach was just being lazy by not wanting to solve a 117 by 117 matrix, but it turns out the T-flow fuzzy was a pretty good idea. So some of the lessons we learned by going through this effort, one was to start our calibration from a single base model in the scenario manager. This was as we were getting into the scenario manager. What we had done, just to kind of recap what Zach said, we calibrated an AM model and we calibrated a PM model separately, and then we decided to go into scenario manager. So we had to create a PM transfer file. Our AM model became our base in the scenario manager, and it got a little messy. So next time what we would do is create our base model, do our error checking of the model, make sure we're good with the model coding, but then bring it into scenario manager before we calibrate the model. And in that way, we could have different modifications in the scenario manager to get us from that base to an AM calibrated and a PM calibrated model. Another lesson we learned had to do with the routes that we brought into VisM from Vizoom. So rather than coding in, I think it says on here somewhere. No, it doesn't. It was like 1,000 routes or something, 1,000 OD pairs. Rather than doing that by hand, we brought them in from Vizoom. But again, we brought them in separately in the AM model and in the PM model. And so when you do that, when you bring in a solved AM OD matrix into VisM, it only creates the routes that have a non-zero volume on them. And so we did that for AM and we did that for PM. And what that meant was that we had some routes in the AM that weren't in the PM and vice versa. And that also kind of created some issues in the scenario manager as we tried to modify some of the routes. We ended up trying to modify routes that didn't exist. And it just got a little clunky. So I think next time what we would do is start with that seed OD matrix that had all the possible routes in it, and use that to create our routes in our base model, so that we would have all the possible routes in both of our models, and we'd have that consistency. And then I always like to throw this in there. Anytime you're transferring between products, Vistro, VisM, Vizoom, just make sure to set aside some time to do a little bit of cleanup here and there. In general, the transition works pretty well, but it's never perfect. And then in terms of some suggestions moving forward, under the more automation category, again, kind of going back to bringing in those routes from Vizoom into VisM, what we found is that when those routes are imported, the vehicle routing decision number, it's probably really hard to see that in the back, but your static vehicle routes are made up of a vehicle routing decision number and then a kind of a route number. And that vehicle routing decision number is coded as your origin zone number. But your destination zone, your vehicle number, sorry, your route number, is just numbered starting at 1 and increasing up to however many routes you have. There's the number. 1,155 routes is what we had. So it just goes from 1 to 1,155. What would have been helpful for us would be to have that second number come in as your destination zone, so that when you look at a particular static route, you could see, okay, this is from zone 1 to zone 43. And so what we did to get around that, we created a user-defined attribute, that column on the right there, the destination, where we matched all that up so that we eventually got there. But more automation there could have been helpful. This is kind of a general comment. And I know you guys have been working on it for years, and you talked about it some this morning, but just generating networks that require less cleanup when you bring them into vSim. And then in terms of signal timings, since we were doing a TSP project and we were optimizing signals between different alternatives, different scenarios, we would code our TSP parameters into our vSim model. Then we would bring our signal timing back into vStro to optimize, and then bring that new optimization back into vSim. But when we did that, we lost our TSP parameters, so then we had to recode those in. So to my knowledge, at least there's not a way to do that yet, but I'm hoping there will be in the future. And then under Scenario Manager, you've already met some of our wishes as you presented this morning with the tree design in Scenario Manager. I say independently, we thought we would be really smart to come up and suggest that to you, but you'd already thought of it, so kudos for that. But we did have some issues with, like I said earlier, some of our modifications conflicting with other modifications, and at times that did cause the software to crash. So I don't know exactly what the answer is, but if there's a way to kind of warn of things, of those unintended consequences and those conflicts ahead of time, that would have been helpful for us as well. Oh, there, I got pointers. All right, and I don't know if we have time for questions, but I'll be done.